Let's do this example. Amy's distances from home after running for 15 minutes and 60 minutes are plotted in the graph. Find a linear function f of t that gives Amy's distance from home after t hours. The first thing I notice here, the horizontal axis units, they're measured in minutes, not hours. There's a couple different approaches we could do. We could find a linear function that gives Amy's distance from home after a certain number of minutes, or we could just convert the horizontal axis units to hours, which would be easy enough because we only need to convert two of them. 60 minutes is 1 hour, and 15 minutes would be 1/4 of an hour. We don't need to convert the others because we only have 2 points, one at 15 minutes and one at 60 minutes. So you may recall from a previous example, we actually found the slope already. We thought of it as a rate of change. It was 6 2/3 miles per hour. We converted it to miles per hour in the previous problem. And in order to work with this number, I'm going to change it to an improper fraction. 6 times 3 plus 2 is the numerator, 20. And then 3 would be the denominator, 20/3. 20/3 miles per hour, if you like. This is the number we're going to need to help us find the equation of the linear function that models this situation. So the next question you want to ask yourself, which of the two forms of the equation of the line do we use? Do we use y equals mx plus b form? Or do we use y minus y1 equals m times x minus x1? The first form is called slope-intercept form. The second form is point-slope form. Since we're not given the intercept, we're not going to use slope-intercept form. That's the rule in this class, to get you to use this equation, to get you to try it. If you're not given b, essentially don't use that equation. Okay, and then later on we'll fill in f of t for y and t for x, but let's just use this equation for now. So now we need the slope. Oh, we already got it. If we didn't have it, you'd have to find it, but that's easy enough. You would just, find the rise here. From 2 to 7, that rises 5. Find the run here. From 1/4 of an hour to 1 hour, that is 0.75 or 3/4 of an hour. And if you take 5 in ratio to 3/4, you will get 20/3. So even if we hadn't done it yet, it wouldn't be too hard to find it. Now, let's fill in what we know. Which point do we want to use as our x1, y1? Well, I claim this point would be maybe a little easier because the time unit here is just 1 as opposed to 1/4. So let's use the point 1 hour, 7 miles. Input is 1, output 7. In other words, after 1 hour, she was 7 miles from home. Okay, well, let's fill it in. We get y minus y1, y1 is 7, equals m, which is 20/3, times x minus x1, which was 1. Let's clean it up by distributing the 20/3. Get y minus 7 is equal to 20/3 times x, minus just 20/3 times 1, which is just 20/3. And then we want to add 7 to both sides to isolate the y. So we're going to add 7. Now, what is 7, though, really? It's really, you have to get the common denominator. And if you think of it as 7 over 1 and multiply by that common denominator of 3, it's really 21/3 that we're adding to both sides. 7, in other words, 21 divided by 3 is 7. Wait, let me clean that up a little bit. Otherwise, we were showing probably a little too much. So on this side, I'll just call it 7. On this side, I'm adding 7 in the form of 21/3. And if we do that addition, we get, just y by itself on the left side, 20 thirds times x, and then remember what you do. You combine the numerators and then keep that common denominator. So it's going to be negative 20 plus 21, which is 1. That's the numerator over 3. So plus 1/3. And then remember, we're basically instructed to call the function f of t, which means we're going to replace y with f of t. And okay, if you use f of t for your output, automatically t is your input. So you've got to replace x, the input, with t, 20 thirds times t plus 1/3. So that's it. That linear function will give you Amy's distance from home after t hours, assuming that she runs at a constant rate, which is a big assumption. You can check your answer here. Look, if you plug in 1 for the input, you better get 7 for the output. And you do. Look, if you plug in 1 here, you get 20 thirds times 1, 20 thirds plus 1/3, 21 thirds, which is 7. And then if you plug in 1/4, 1/4, so if you plug in 1/4 instead of 1, the output had better be 2. And it will be because, okay, if you take the 4 into the 20, you get 5 thirds here. When you take 20 thirds times 1/4, you get 5 thirds, plus 1/3 is 6 thirds. 6 divided by 3 is 2. So you can check your answers here by plugging in both points that you're given. And one last thing I want you to think about here. We've already mentioned that m is equal to 20 thirds or 6 2/3 miles per hour. That's the slope. M stands for slope. We get the units of slope by taking the rise units in ratio to the run units. But I also want you to think about what this 1/3 represents. It's the y-coordinate of the y-intercept. If you think about y equals mx plus b form, well, that's not quite how we're writing it here. Here it's f of t instead of y, and t instead of x, so f of t equals mt plus b. But we could still designate the y-coordinate of the y-intercept as b, and it is 1/3. So what does that mean? Well, remember, the y-intercept is a point, and it has coordinates 0, 1/3, 0, comma b. So what that means is Amy was 1/3 of a mile from her house at time 0 when she started running. In other words, assuming she runs at a constant speed so that we have a straight line here, the y-intercept, if you extend the line here, is going to be right about here. So she didn't start running when she was at her house. She started running when she was 1/3 of a mile from her house.